Okay, hello students. So I will make this short video for you because I gave you the presentation but also without my voice. So I will make it some small comments on it. So this lesson will be about acids and bases. So it is a really important question, so you better know what is acids and what are bases. So in your everyday life, you know that acids like acetic acid and citric acid. Citric acid is in lemon. You can find, and acetic acid is vinegar. So it is used for cooking. So also bases you also know some baking soda, for example. This is easy to use for cleaning. And ammonia hydroxide, it is ammonia water. It is smell nasty, and it is used sometimes for housework. Okay, other examples. Okay, as I said, vinegar, lemon juice, and also you have in cars you have sulfuric acid. They call it battery acid. And you can have a can of soda. Soda has inside also acid, but weak acid. It is acid is actually dissolved CO2. It is very weak acid. And then bases also, as I said, baking soda and ammonia, but also less strong bases. It is like soap and borax. In science, people agreed to use so-called pH to measure acidity and alkalinity of the solution. So the pure water, people just agreed that let's make pH of pure water is 7, and acid solutions can be pH less than 7, and alkaline solutions pH more than 7. Okay, so and then it depends. There is some separation between strong acid and bases and weak acids. Strong acids and bases are 100% ionized in aqueous solution. What it means? That chemical composition, that molecule of hydrochloric acid, H-chlor, it is decomposing. It is like in water. It consists of not this as molecule, but as ions. Ion of proton, and chlorine as positive ion, and the same other strong acids. Strong bases the same. There are not so many strong bases. It is like a good example, sodium hydroxide, and if you dissolve it in water, it is also exists in water as ions, positive ion of sodium and negative ion of hydroxyl ion, and potassium hydroxyl the same. Weak acids, they have the pH only in the range from 5 to 7, and good examples like acetic acid in vinegar, benzoic acid. Okay, normally you don't have it, don't work with it. Oxalic acid is in many vegetables. So it is really, I was talking about this oxalic acid. It's very nasty. It's very bad substance. Okay, and then we have weak bases, and with pH from 7 to 10, and examples are ammonia, this ammonia water, and zinc hydroxide. Zinc hydroxide is very weak base. pH means potential of hydrogen. Potential, this is just abbreviation, potential hydrogen, pH. But again, it's not necessary to get to the definition, scientific definition. Just remember that pure water has pH 7, and acidic solution have pH less than 7, and alkaline solution have pH greater than 7. That's all. And scientists agreed to give some scale of acidity and alkaline composition. So it is like in colors, so it can be from red to violet color, and neutral is green. So this color corresponds to color of special indicator solution. So you can use some special pigments that change color in different solutions, alkaline or acidic, or alkaline. Okay, then another much more easy and much more convenient to measure alkalinity, to measure pH with such small device. You can buy it. It is maybe, I don't remember for sure, but maybe 200 baht only. So it has electronic indicator, and it shows you the pH of solution. So it is easy to use instead of this special pigments, special chemicals that change color. So this works much more easy, and so in laboratories people already a long time use such measurements of pH. Okay, then again, as I said, strong acids and bases both they dissociate into ions. So it is again, they don't exist as molecule but as ions. Positive ion like of the metal and hydroxyl if it is alkaline solution, or it is hydrogen and chlorine and hydrogen. The hydrogen exists in water solution as proton. Proton is positively charged ion. And then what is also difference between acids and bases? Acids, they produce proton, they give proton, and bases, they take proton. They take proton means they can react with bases and bases and acids can react. Okay, then this is also a good example of what a scale of from 0 to 14. This is quite extended range of alkalinity or acidity. Some very strong acids, they have very high acidity. It's like pH 0, even 0. It is very high acidity. In some alkaline solutions, very concentrated, they can have pH 14, even 14. Okay, examples of the strong acids and bases. And the sulfuric acid, you probably, as I said, it is in car. In the battery of the car, they use sulfuric acid. Hydrochloric acid, you can buy this acid to clean your toilet. Nitric acid is not much in use but okay, it's also very strong acid. And weak acids, carbonic acid. Carbonic acid, as I said, it is in a can of soda. You open it, and the carbonic acid is not stable. It is disintegrated with the release of CO2 and water. But but when you drink, you feel that this water with gas, it has some acidic taste. Okay, then other substances like phosphoric acid, it can be used. Sometimes it can be used. Okay, and the sodium hydroxide are used in your kitchen to clean the pipes from some deposits of fat, for example, and potassium hydroxide the same. And sodium hydroxide and potassium hydroxide are used to produce soap. So this is one of the interesting application. Okay, ammonia, as I said, it is used for cleaning also. And here again some examples of strong acids and weak acids. And the weak acids, among of the weak acids, acetic acid and oxalic acid. Oxalic acid and acetic acid widely present in food. And oxalic acid is very nasty, so it's very bad for health. Again, here examples, so I just give some example, and again I show you that strong acids, they decompose to proton and negatively charged ion of chlorine. Okay. How acid and base react together? They react to produce salt, and then in water. Okay, so here some example of the reactions. So the sulfuric acid can react with calcium hydroxide. Calcium hydroxide is another name lime. Lime, it is used for to make concrete, and also it is used as a pigment to walls. It has white color. So if it will react, it will produce gypsum. Gypsum is calcium sulfate in water. So, okay, so somehow it is. Yeah, actually, yeah. Here it is calcium hydroxide, but what is interesting, if you take calcium oxide and add water, then it will be it will transform to calcium hydroxide. So it reacts with water with and calcium hydroxide may appear. But if you take calcium oxide and as powder and put to sulfuric acid, reaction is the same. You will get gypsum and some water, but not so much water. It's because it is some water consumed. There is a reaction which is important again, how strong acids, again, and I repeat, strong acids and bases react with metals. You have to remember that not all metals react with acids, not all. They have to be active metals. It is not so many such active metals. Zinc is one example that zinc reacts with sulfuric acid and with chloric acid, and there is the release of hydrogen gas. And also salt of zinc sulfoxide can be produced, and this go to solution. It is dissolved in water. The same sodium hydroxide solution can react with zinc and will produce hydrogen. Pardon. But again, not all metals react with acids and bases. Some metals, like stainless steel, for example, this alloy, which does not react with acids and bases. Okay, so we can see that pardon, salt and that acid base can react with metals. Okay, that's all. You are supposed to go through the quiz, and please answer the question, and I will collect books. You can work as a team, you can work personally, use internet, work in teams, and use books. And you are supposed to collect books with your answers and give it me for checking, and then I will give the score. So that's all. Thank you.